Hello everyone and welcome to today's video. In today's video we will be solving the BECE 2010 past questions and basically finding the answers. So without much further ado, let's get into today's video. We begin with question 1. Which of the following sets is well defined? We have options A, B, C, and D. You can pause the video to choose one and then see what our response is, but the answer is 1D. The set, Seth, Mary, Jacob, and Evelyn. 1D is our answer because 1D is the most well-defined identity that we have. That is a consistent feature or element running through each and every one of the participants of the set. In this case, it is the names of persons. That is, Seth, Mary, Jacob, Evelyn are all names of persons, and so you can see that this is a well-defined set. However, if we take an example like A, we have man, Kofi, red, 14. If you notice, it's a mixture of a name, color, numbers, and hence the set isn't exactly well defined because it seems to be a mixture and a jumble of elements and not specifically one consistent element that runs through them. Now to question 2. If set B is a subset of set A, then we have options once more, A to D. Our answer is D. All the members of set B are in set A. With question 2, you're most likely to confuse D and B because with B, we have some members of set B can be found in set A. Whilst this is not necessarily wrong, it is a half-truth. Because yes, some members of set B can be found in set A, but in actual fact, that is so because all members of set B are in set A because set B is a subset of set A. And so hence, D is our answer for question 2. Now moving on to question 3, we have the least common multiple of 16, 30, and 36 is. To do this, what I'm going to do is I'm actually going to work on helping you understand the basis and concept of what a least common multiple is. I believe that once you have that understanding, it will be easier to answer the questions via any approach, whether the approach would be formula based or whatever means you use to find the answer. Once you have understanding, that's a good way to start. So when we talk about least common multiple, what are we saying? We're saying that when we take a group of numbers and each of them, we list out their multiples, the multiple that is common to each of these numbers and is the lowest is the least common multiple. Okay, so I understand if you didn't really get what I just said, but I'm going to use the examples 2, 4, and 8 here, and I just want you to try and visualize it with me as I explain. So for example, we have 2. Multiple of 2 is 2 in itself because 2 times 1 will give you what? 2. It proceeds. We have 2, 4, 6, 8. These are all examples of multiples of 2 in that order. Now let's take 4. With 4, it starts from 4 in itself. So we have 4, 8, 12, 16, and it proceeds. And then finally for 8, it starts from 8 and it proceeds 8, 16, and so on. We've been able to list out the multiples of 2, 4, and 8. Now let's find the lowest common multiple of 2, 4, and 8, or the least common multiple of 2, 4, and 8. The answer for the least common multiple of 2, 4, and 8 will be 8. Why is this so? Because 8 is the only number that is common to 2, 4, and 8 as multiples of each and every one of these numbers, and is the lowest we can get. It's the lowest because it's the first. Obviously, when we proceed, we have 16, which is also a common multiple to 2, 4, and 8. But 16 cannot be the least common multiple when 8 exists. So the least common multiple is more like the first multiple of each of the numbers that is common to all of them. I'm not sure if you actually understood this, but you can try and play the audio again to see if you got what I was trying to explain. But now, to make it more practical and bringing it down to the example that we have, let's look at the question. Now, obviously, option A and option B are definitely cancelled out because 3 or 6 can never be multiples of 16, 30, or 36. And hence, it's not an option because they are lesser than each and every one of these numbers. However, we have 240 and 720 as our solid options now. So what we're going to do is we're just going to see if 240 is our answer or 720 is our answer. Whilst this is kind of like a try and error method, mind you, there are formulas to the use of finding least common multiples that you can always apply. In this particular question, I'm just really going to work with helping you understand the basis and concept and applying it to the question to get our answer. So for 16, right, we divide 240 by 16 and we get 15, making 240 a multiple of 16 because 16 times 15 will give you 240. With 30, we have 30 times 8 and that will give you 240, making 240 also a multiple of 30. However, when we come to 36, we have 20 divided by 3 being the multiplication by 36 to give you 240. Now, here's the issue. It means that 240 is not a multiple of 36 and automatically 240 is cancelled out. Why is this so? Because fractional forms, decimal forms, multiplying other numbers to give you an answer does not make that answer a multiple any longer. They have to be whole numbers like the ones we experienced in 16 and 30, and hence 240 is obviously not our option any longer. That leaves us down to 720. Now when we come to 720, you would realize that 16 will go into 720 45 times. It will go into 30, will go into 720 24 times, and 36 will go into 720 20 times. Of each of them, 16, 30, and 36, they are all each multiples of the answers we have. So 720 applies to 16, 30, and 36 as multiples of each of these numbers, and it's also what is most common to them, and in that fact the least common multiple, because there is actually no other multiple before 720 in the options we currently have as well. Our answer hence is 3D. Question 4. The sum of 5 and x divided by 4 is equal to 3.25. We are to find the value of x. The first thing you do is construct your equation. In constructing our equation, we are told we first find the sum of 5 and x and divide that as a whole over 4 and equate this to 3.25. Okay, so when that is done, what are we going to do next? Our next move will be to remove the fractional form we have, which is 5 plus x divided by 4, so we're going to try and get rid of 4. We multiply 4 on the left-hand side and on the right-hand side, wherein 4 going into itself would cancel itself out. And 3.25 times 4 will give us 13. Now, I did the calculation on the side here. If you are using the GES syllables or following the GES BECE syllables, from what I've understood, unless there have been changes in the curriculum so far, you do not use calculator at that level of your math education, and hence you must be well acquainted with decimal multiplications and fractional multiplications and decimal divisions and fractional divisions. And hence the reason why I just decided to do it on the side. If you're not good with it, practice it because you can understand the process and know how to get the answer. But these small things can trip you. And if you notice, objectives does not mark process, it marks answers. So bear that in mind. So now we move on to 5 plus x is equal to 13, and we make x the subject. With x the subject, we're going to have x is equal to 13 minus 5, which gives us 8 as our answer, making A the answer for 4. Now we proceed to question 5. Question 5 is a bit more heavier than all the other questions. That's the thing about objectives. There's a balance of questions that require more attention as compared to the others. So you must be able to gauge your time really, really well and the approach you use in solving your question. Sometimes it could be cumbersome, sometimes it could just be time consuming, and sometimes you can look for straightforward means. However, one thing I always say with maths, once you practice, right, and you understand the basis and concepts that make maths up, solving questions become a bit more easier for you to handle because you can always find an approach towards things. So let's get right into it. I don't want to talk too much, but these are just tips I'm leaving on the side to help you in your preparation and in your practice with these questions. We have for question 5, the numbers 32, 33, 34. Then we have 2 dashes and 42 form a sequence in base 5. We are to find the missing numbers. Okay. So what are we going to do? The first thing is we have to recognize that these numbers that have been given to us in a sequence form are in base 5. We can obviously not solve it in base 5, so we have to convert these numbers in base 5 to base 10. Find out the missing numbers and then convert these missing numbers that we have identified back to base 5 to find our final answer. Now, if you didn't get that, that's okay. It's just a summary of what we're about to do. So let's get right into it. For 32, I'm going to start numbering 5 to the power 0 from the right hand side moving to the left hand side. So we start from 5 to the power 0 on 2 and 5 to the power 1 on 3, and it actually proceeds in that way if there were more numbers. So if there were more numbers, we'd have gone ahead to say 5 to the power 2, 5 to the power 3, and all that. But in this case, it's just 5 to the power 0 and 5 to the power 1. I'm going to do the same for all the others. Okay, now that that is done, what are we going to do? We're going to multiply 3 times 5 to the power 1, which is 3 times 5. Anything to the power 1 is itself. So 4 to the power 1 is 4. In this case, 3 times 5 to the power 1 is 3 times 5 plus 2 times 5 to the power 0. Remember, anything to the power 0 is 1. 4 to the power 0 is 1. 2 to the power 0 is 1. And in this case, 5 to the power 0 is also 1. 3 times 5 plus 2 times 1 will give us 17. This answer is in base 10. We apply same to all the others. We have 3 times 5 plus 3 times 1 giving us 15 plus 3, which is 18. And then we have for 34, 3 times 5 plus 4 times 1 giving us 15 plus 4, which is 19. And finally for 42, we have 4 times 5 plus 2 times 1 giving us 20 plus 2, which is 22. Now you see that we have been able to form some sort of sequence in base 10, which is an addition of 1 from 17, moving on to 18, moving on to 19. We have 2 missing numbers and then we jump to 22. Obviously, it means our missing pair will be 20 and 21. We've solved the first piece to the puzzle, which is we found the missing numbers in base 10. Now we have to convert these missing numbers in base 10 to base 5. Okay, so with that said, let's move to doing that ASAP. Now we have 20. We have 5 to the power 0 and 5 to the power 1. We're going to divide 20 by 5 to the power 1 because 5 to the power 1 will give us 5. Now we have to divide 20 by a number that can go into itself, and so that number has to be smaller than 20 and not bigger than 20. Hence, the reason why we're choosing 5 to the power 1 to go into 20 and not maybe, for example, 5 to the power 2 or 5 to the power 3 or 5 to the power 0. Yes. So there's 5 to the power 1. 20 will go, 5 will go into 20 how many times? We're going to put R on the other side as remainder. So we put all the remainders on that side of the column. 5 will go into 24 times and record 0 on the remainder side. And 5 cannot go into 4. So 5 into 4 will be 0. And then we transfer the 4 to the remainder side. Now, in converting this to base 5, we're going to convert it in an upward form. Hence, our answer will be 40, which is 40. And so, converting 20 in base 10 to base 5 will give us 40. We do the same for 21. 5 will go into 21 4 times, remainder 1. 5 cannot go into 4, so we put 0 and we transfer the 4 to the remainder column, giving us what? In upward form, 41. Hence, our missing numbers or our answers will be 40 and 41. We move on to question 6. We are to write down all the integers in this set. Let's get our basics right. First things first. With integers, we have negative and positive integers. Since that has been established, now also with integers, we do not have fractional forms or decimal forms or even square root forms. None of these can qualify as integers. With that knowledge, let's look at the options we have and figure out which ones are integers. That means that for set A, -10, -4, 0, 45, and 100 are integers, to exclude 1/4 and 2.5. Because these fractional forms do not qualify as integers, making our answer for question 6 A. Now to question 7. We are to find the total cost of 25 pens and 75 books. If each pen costs 20 pesos and each book costs 30 pesos. Okay, so we find 25 times of each of these pens, which cost 20 pesos each, and 75 of these books, which cost 30 pesos each. We form our equation 25 times 0.2 plus 75 times 0.3. Okay, so this is not an equation because it does not have an equal sign, but basically we place it in this form to be able to find our addition. Yes, and 25 times 0.2 will give us 5. 75 times 0.3 will give us 22.5. When we add 22.5 plus 5, mind you, this means that you have to really get your decimal addition strong on, so that solving these types of questions would not leave you dependent on calculators. But 22.5 plus 5 will give us 27 CD 50 pesos, which is 27.5. Our answer will be 7C. Then for question 8, we have -27 plus 18 minus into bracket 10 minus 14 minus into bracket -2. First things first, clear the brackets. Solve what's in the brackets. So we're going to start with 10 minus 14. 10 minus 14 will give us -4. Now, with positive and integers multiplication, we understand that negative times negative will always yield positive. And do we see this happening? Yes, we do. So we have negative times -2, which will become +2, and negative times -4, which will become +4. Hence, we have -27 plus 18 plus 6, which will give us -27 plus 24, our final answer being -3, 8A. Now to question 9, we have to arrange the following numbers from the lowest to the highest. We have 0.5, 3, -5, and 0. We're going to start from negative numbers because negative numbers are always lower on our scale. So -5, between -5 to 0, we don't have any more negative numbers. So it means what? The next lowest number is 0 in itself. 0 will proceed to 0.5 and 0.5 to 3, making our answer -5, 0, 0.5, and 3 in that order from lowest to highest, making our answer 9C. Now finally with question 10, we are to find how many pieces of cloth 5.5 meters long can be cut from a roll of cloth 121 meters long. What are we trying to say in this question? We have a huge piece of cloth, a huge amount of cloth 121 meters long, and we want to know how many pieces we can get if we cut this 121 meters long cloth into 5.5 meter pieces each. So for each piece will be 5.5 meters. Then how many pieces can we get from this 121 meter long amount of cloth? To do this, we're basically going to divide 121 by 5.5. 121 divided by 5.5, we're going to convert 5.5 to an improper fraction. If you don't know how to do it, just go back to your basis on conversions with improper fractions, right? So 5.5 converted back to an improper fraction will become 11 out of 2. Now there's also a principle under which division with improper fractions follow. And that is, if you have 121 divided by 11 out of 2, to find this division, we're going to reciprocate the 2 and the 11, taking 2 on top and 11 at the bottom, and multiply this now by 121 to find the division of 120 by 11 out of 2. So now we have 121 times 2 out of 11. 11 will go into 121 11 times, and 11 times 2 will give you what? 22. Hence, our answer for 10 is D. And now we've come to an end of today's video. You can check the next video